Welcome back. So today we're going to talk about transforming functions. All right, we're going to take a break from merely dealing with polynomials. We're going to talk about transformations in general for all these types of functions that we can talk about. Now, this you should remember. You've seen this quite a bit, but let's do a quick review. So when you have something multiplying out front, remember that is creating a stretch if it's a number greater than 1, or compression if it's less than 1. And if that number is negative, that means you have an x-axis reflection. So that's all based on this a value right here. Remember, if the x is being shifted, that means you're either shifting left if you see a positive there, or being shifted right if you see a negative there. Remember, that one is the one that's opposite of what we'd expect. Okay, so a little bit weird, but the x will shift opposite what you think. A positive will mean shifting left, a negative there will mean shifting right. And then finally at the end, if there's a number there, if it's positive, that means it's shifting up. If it's negative, it means it's shifting down. So again, all stuff that you've seen, but we just need a little refresher on. So let's take a look here. So for each parent function, describe the transformation. So the first thing that I notice is that number multiplying out front. Remember, when there's a number multiplying, if it's greater than 1, that means it's a stretch of 2. When my x is being shifted, remember it's shifting in the opposite direction of what you want to think, so that is actually shifting it to the right 1. And finally at the end, this plus 3 means it's moving up 3. So to describe the transformations, that's what I expect to see. Now for this one, I see a negative out front. So there's no stretch because there's no number there, but that negative means that there's an x-axis reflection. My x is being shifted, plus 2. Well, remember, it works the opposite of what you'd expect, so that is actually sending it to the left 2. And then that negative 5 at the end means down 5. All right, this one here, I notice this number multiplying out front. Now this time notice it's a fraction, it's less than 1. So instead of calling it a stretch, I'm actually going to call this a compression. Okay, if it's fractional, if it's less than 1, we just call that a compression. Now I notice my x isn't being shifted at all. There's nothing being added or subtracted from my x. So there actually is nothing moving it to the right or left. So I can jump straight to focusing on this minus 4 at the end. That minus 4 at the end just means down 4. So another good thing to remember is in every one of these, you're not going to have every type of transformation. Just identify the transformations that are actually there, and those are the ones that you focus on. Now you've reviewed how to look at an equation and describe the transformations. Another skill is being able to just look at the transformations and create the equation from that. So let's take a look at this. So a parent function of y equals x squared, and we want a stretch of 3, left 4, and up 2. So remember that stretch of 3 is going to be that first number out front, okay? So how is my x shifting? So we know we have an x squared function. So I'm putting the parentheses with the squared there. And now shifting left 4 Well, remember, that means I have to add 4 to that x. Remember, shifting oppositely from what I'd expect. So if it's shifting left 4, it means my x is being shifted plus 4. And then at the very end, up 2. So that's really how you can do these. Okay, so create the basic skeleton and then put the multiplier out front for your stretch, shift your x to go left or right, and add or subtract at the end to shift it up or down. So let's take a look at this next one. So x-axis reflection with a compression of 1/3. So that means I have a 1/3 multiplier out front, but it needs to be negative because I have an x-axis reflection. So that's what it looks like to have an x-axis reflection with a compression or stretch. You have a negative with that number. And now I'm going to set up my x. So what's my x doing? Well, my x is shifting to the right 2. So to go to the right, again, is the opposite of what you'd expect. So you're going to have a negative 2 there. And then at the very end, you're going to go down 1. Looking at our next one. So we have stretch of 2. So I'm going to have my 2 there. Have my basic skeleton with my x. Now my x is moving right 3. So go to the right, again, opposite of what you'd expect. And now notice there is no shifting up or down. So that means that's actually all. I don't have any number in back adding or subtracting it. I can just leave it like that. All right, then y equals, well, in this one, there's no x-axis reflection, no compression or stretch. So this one has no number multiplying it out front. So I can just jump to setting up my x. And it's shifting left 1. And again, to go left is the opposite of what you'd expect, that plus, and then down 4 means you subtract 4 at the end. All right, so that is all in terms of these transformations. So, as always, make sure you have all this written down, and then come and see me if you have any questions.